Okay. So, and let's go through all three of them. I wanted you to do two things with these problems. The first thing I wanted you to do is I wanted you to name the type of curve it is. Is it a hyperbola? Is it an ellipse? Is it a circle? There is one more that we haven't totally discussed yet, so I didn't put it on. There is also a parabola. Those are the four types of things that are called the conic sections. They're the figures that we get, the shapes that we get when we draw the, the graph of a quadratic equation, something that has an x squared. And if you notice, each one of these not only have an x squared in them, they also have a y squared. They are all quadratic equations. So, Stacia, what made you say that this one is an ellipse?
because it was equal to 1.
Okay. Well, it isn't. It's equal to 81. What makes it an ellipse? What made you say that one has to be an ellipse? And then you said this one is a hyperbola. And how did you didn't where did you get to that?
Because I did the working out and I had like 1/9
Okay.
x
You put
squared plus 1/81 y squared, and I equal it to 1. And then I had the x squared over 9.
what she did is she put this in standard form. Notice 2 is already in standard form, but 1 was not in standard form because it wasn't equal to 1. So what did you get in the end?
Cortito.
X squared over 9
Yeah, and y plus y squared over 81.
equals 1.
Yeah.
And we know, so I'll explain. Obviously you could look at it, but I'm going to tell you how you can tell. First of all, the a squared and the b squared are different numbers. As soon as these are different numbers, and you could have seen it right away, the coefficient of the x squared and the coefficient of the y squared are different. One it has a coefficient of 9, one has a coefficient of 1. You could have seen it originally or in the standard format. And on top of that, between the two terms, between the x squared term and the y squared term, there's a plus. When these are different numbers and there's a plus in between them, you have an ellipse. You are absolutely correct. This one is an ellipse. Let me write it over here. Okay. So what made you say this one was not an ellipse then? Stacy, I'm still talking to you because you
Oh,
gave
okay.
this first.
It was already equal to 1. So what
Right.
I did, I had x minus 0 squared and y minus 0 over 4 to the second power and 6 to the second power.
Okay.
I found the square root of 16, which is 4. The square root of 4 is 16, and the square root of 36 is 6.
But what I'm asking you, you're absolutely right in what you're saying, but I'm asking you, what made you think this one has to be an hyperbola? Before you did any work, what was the difference between this type of an
That
equation?
had a plus and that had a minus.
Absolutely. That's what makes this the hyperbola. If you look at the equations of the ellipse and the hyperbola, they look so similar. The difference is that in an ellipse, you're going to have a plus. In a hyperbola, you're going to have
a minus.
A minus. This is not working very well. Don't know. Since they're all black, it's hard to tell. I can't remember which ones were good and which ones weren't. So this one is a hyperbola. Now, Cheryl, I see you said this one is a circle. How is this one different than these two. Cheryl, you want to tell me or you want me to do the explanation?
You can do the explanation.
Okay. You're absolutely right. This is a
Yeah.
circle.
Mhm.
If you notice, first of all, it has a plus, so it couldn't possibly be a hyperbola. If this would have been x squared minus y squared, then it would have been a hyperbola. The thing that tells you that you have a hyperbola is when between the x squared and the y squared terms, you have a minus. But when you have a plus, it could either be an ellipse or a circle when the coefficients of both the x squared and the y squared are 1. They're not over anything. If you would have divided everything, you'd get them over. If you would have tried to put this in what we call standard form, you could have done that, but we usually don't do that with a circle. Both the numbers over here would be the same. That's what makes it a circle. In this case, usually we don't even go any further. Once I see just a plain x squared and a plain y squared, it's not over anything, which means it's over 1. The coefficients, the numbers in front of the x squared and the y squared are both 1, then what you have is a circle. Now, the second part of my question was to make a sketch of each curve. So I'm going to go over to the other side of the board and I'm going to do a sketch of each one of them. Remembering I know what the shape is going to be like. I know what the shape of an ellipse is. I know what the shape of hyperbola is. Knowing what type of shape you're going to get, especially if you're going to have a multiple choice question and two of them look like ellipses and two of them look like hyperbolas, without doing any work, you can eliminate some of the answers. So that it's very good to think, what does this going to look like? Now, in this one, again, when you're dealing with the ellipse and the hyperbola specifically, you want them in standard form. Stacia did tell us how to put this one in standard form. In that one, we get that the a squared is 9, which means the a will either be plus or minus 3, because you take the square root. And the b squared, which is the number underneath the y squared, is 81, which means that the b will either be positive 9 or negative 9. Remember, I use this symbol to make it easier to write. I don't have to write it twice. So when I go to draw this, on the x-axis, I have to go 3 to the right and 3 to the left. Here's my positive 3. Here's my negative 3. Of course, in this case, the y is 0. My x-intercepts are 3 and negative 3. On the y-axis, because that's what the b gives us, is the y-intercept, I go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's my positive 9. And I go down to negative 9. And this gives me 4 points that I connect with a oval shape. And this is what my ellipse will look like. Okay. Can I erase this so I can do the second one? Anybody still need time to copy this?
Don't erase it yet.
Yes, yes, Miss.
Okay. Okay, in the meantime, I'll start talking about number 2. And I'll do it. Number 2, we didn't even have to put it in standard form because it was already in standard form. It equals 1. So I just have to figure out what the a squared and the b squared is. So in number 2, the a squared is 16 and the b squared is 36. But since this is hyperbola, it's not going to have both intercepts. It's only either going to have x-intercepts or y-intercepts. And I can tell by looking at the one that's positive. The x squared is positive. There's a minus in front of the y squared. When the one that's minus will never be able to give us a intercepts. So we aren't going to have y-intercepts. We'll just have x-intercepts. My a is going to be plus or minus 4. Sometimes we have the x squared minus the y squared. That means the x squared is positive, which means we have x-intercepts. Sometimes it's written y squared minus x squared. In that case, then you have y-intercepts and not x-intercepts. Whichever one is positive is the one that's going to give you the intercepts. Can I erase this now? Can you do more? I'm sorry, I didn't read what you said. I don't know how to I'm sorry, I don't know, Kachira, how to handle an iPhone at all. My phone is a standard Android, so. Okay, let me finish this and yes, I'll try and make it clearer.
Miss Pearl, did you do attendance yet?
No. No, I did not. Okay, so let's look at this. It's when we have a hyperbola, again, we know it's hyperbola because of this negative sign in between them. In the ellipse, there's a plus sign. In a hyperbola, there's a minus sign. So when there's a hyperbola, we look for the one that's positive, which in this case is the x squared. That tells us we find the a. These are the x-intercepts. It means that if we go to 4 and -4 on the x-axis, we're going to get, remember, the hyperbola is that strange shape that is 2 back-to-back u's. So you're going to get, and I don't know why to make these u's, but you don't have to worry. What you have to do is now they're supposed to look exactly alike. They're supposed to be. Sometimes they're narrower, sometimes they're wider. But what we're going to be looking for this course is just to see, are they going through the right numbers and are they going through the right axes? They don't cross the y-axis. They're just these back-to-back u's. They're sideways u's in this case, facing away from each other, going through 4 on the x-axis. Any question about that? Okay, I'll do the sketch of the last one up here. Number 3 has x squared plus y squared equal 81. And this is actually the very first type of equation that we talked about in this chapter on conic sections. This is a circle. Anytime you have a plane x squared plus a plane y squared, there could be other things happening. There could be x's and y's, other things. But the x squared stands alone, the y squared stands alone. There's no number in front of it. It's not over any number. If it's over any number, if they're put over any number, then the two numbers they're over have to be exactly the same number. That makes it a circle. You don't even, we don't even talk about standard form for this. This is a circle whose center is at the origin and whose radius is,
You know it, the square root of 81.9 or square root of
I'm
9.
sorry, what's the,
Yeah, I'm saying that this was the easiest one because
Right.
all I had to do was just put everything, the x and the y to 0 and find the square root of 81.
right. So therefore, when you want to draw this, you just have to go 9 in every direction. 9 to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 up, 9 to the left, and 9 down. And if you connect them, you get this circle. The look of a circle, I know this is a very bad looking circle, should be rounder, but the look of a circle and the look of an ellipse are similar. This, if you took a circle, or think about a balloon, if you had a perfectly round balloon and then you started squeezing it, it wouldn't be a perfectly circular anymore. It would be more oval shape, and that's what happens when you go from a circle to an ellipse. So this is a circle whose radius is 9, and its origin, the origin is its center. Is that clear now to everybody? Any other questions? Let me look at the questions. Kachira, are you following it better now? Okay. All right, let me just give you a little bit of the plan going forward. We have 3 weeks of class, including today. Today, I'm going to finish up the last type of conic section, which is a parabola. And starting on Thursday, part of the class will be review. And I will just give you problems of the type that you're going to see on the final, and we'll discuss how to do them if people are not sure how to or don't remember how to do. Let's say I give you a absolute value equation. We'll go through what I am also going to be sending you. Look out for it on your, I guess I'll put it on what we call the information page, is a outline of the course with all the different topics that we covered and 1 or 2 examples on each topic so that you have a quick review of all the topics. I suggest you look through this. I'll give you on the outline, I call it a study guide. It'll have all the topics, some questions on each topic, and then I'll send you an answer key for that study guide, so that you can test yourself and see if you remember how to do the different topics. Again, we're going to be reviewing in class. I'm not spending days reviewing. I'm doing new work part of the time, review part of the time, starting on Thursday. Okay, so what I want to do now is talk about the last type of conic section, the last type of graph that we get when we have a quadratic equation. As I said, there are 4 types. We've just reviewed 3 of the types. The last topic here is parabola. And the shape of a parabola is like a U. And either you'll have a U opening up, or you'll have an U opening down. Very occasionally you have sideways U's, but you are not responsible for those type. We're only going to be doing what are called vertical parabolas, parabolas that either open up or open down, either a regular U or an upside down U. Remember, the hyperbola is 2 U's, one back to back. This is only 1 U. It's not exactly the same shape. The parabola is a little bit more pointy if I had to explain the difference in the shape of the U. But basically they're U's, but this is a single U. The hyperbola always has 2 U's, one back to back with the other. Okay. What's different about the equation of a parabola is the fact that in a parabola, we don't have both x squared and y squared in the equation. We're just going to have an x squared. The y will be linear. The y will be a y will stand alone. The x will have an x, the highest exponent we're going to see on the x is going to be 2. Now, on the sideways parabolas, again, you're not responsible. In that case, you'd have a y squared, but then there wouldn't be an x squared. So only one of the variables is squared. Again, we are going to be talking about the type that looks like this. Y equals ax squared plus bx plus c, where there's an x squared term. There could, or there might be, or there might not be an x term. There might not be a number, but there certainly is going to be an x squared term. But if you notice, there's no y squared term. That is what characterizes a parabola. And suppose I gave you an equation that looks like this. Y equals x squared plus 6x plus 5. If you notice, it looks very similar to a quadratic equation, except that in place of the 0 in a regular quadratic equation, this would be equal to 0. Here it's equal to y. There are 2 important things that we're always going to be looking for. Number 1, we're always going to be deciding whether this parabola should be one that opens up like a smile, or one that opens down, in other words, looks like a frown. And that's something you could always tell by the value of the A. In this case, we know that the A is 1. It's a positive number, which means that you're going to have an opening up U. It's got to look like a smile. A is positive. When somebody's positive, they're smiling. Keep that in mind. So that's number one, the important thing. Does this open up or does it open down? The other important point, probably the most important point that you're going to want to find on a parabola is something called the vertex. Sometimes it's also called the turning point, because when you have a U shape, let's say it's something like this, an U shape opening up, then if you're traveling along the parabola, you're going down, 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 until you hit this point, and then you turn around and you're going up, 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 up. So it's a turning point. It changes the direction of your travel. It's not like a straight line that if you start going up, you're always going to be going up. Or if you're going down, you're always going to be going down. With a parabola, you're going to either start going down and then turn around and go up. Or if you have the opposite type of parabola that opens down, you're going to start going up and then you're going to be going down. So you're going to be turning around. And the point that you're turning around is either called the turning point or the vertex. And that's probably the most important point that you want to find on your parabola. And there's an easy way to find that with a formula that you must memorize. X equals negative b over 2a. In this particular case, as we mentioned, our a is 1, our b, the number in front of the x, is 6. Notice if there wouldn't be any x term, then your b would have been 0. And your c is 5. So if I want to find what the vertex is, I put x equal to negative b, which is negative 6, over 2 times 1, because my a is 1, which gives me negative 6 over 2, or negative 3. Now that's not the end of it, because a vertex is a point. And we know that every point on the graph needs not just an x number, it needs a y number as well. It needs coordinates, an x coordinate and a y coordinate. So what do? Once I have what the x is, I can figure out what the y is by substituting it into the original equation. The y is equal to x squared. Well, now we know my x is negative 3. So negative 3 squared plus 6 times negative 3 plus 5. And working that out, negative 3 squared is positive 9. 6 times negative 3 is minus 18 plus 5. So this becomes 14 minus 18, which gives me negative 4. And now I know what my vertex is. My vertex is the point negative 3, comma, negative 4. So whenever we're asked to find the vertex of a parabola, we have to do 2 things. We have to figure out this negative b over 2a to get the x value, and then take that value and stick it back into the original equation to get the y value. Here's what that parabola is going to look like, approximately. Remember, I'm only doing sketches. I'm not doing major graphs. This is just a sketch. I go to the point -3, -4, which is right here. That's my vertex. That's my turning point. And I know that this is a U that goes up. So therefore, it's going to look something like this. Not really as opposed to, let's, I guess that's a little bit better. This is approximately what my parabola is going to look like. It's going to have a vertex at the point -3, -4, and it's going to be an opening up parabola because the A, which was +1, is a positive number. Now, there are two other things that are sometimes asked for, though if you were looking at sketches of this, if that you were given and it said, here's the parabola, which is the correct sketch, try to locate make sure its vertex is at the right place and make sure it's opening up or opening down properly. The other things that you might be interested in finding are the intercepts. Just like we did the intercepts for the circle and for the ellipse and the hyperbola, this also has places where it crosses the x-axis and the y-axis. Now, in terms of the y-intercept, I know I'm doing it sort of backwards, but the y-intercept is easier. There's only one. There's only one y-intercept. If you notice, there could be two. There could be just one x-intercept, or there could be no x-intercepts depending on the location. Like if your parabola was starting over here and opening that up, there would be no x-intercepts, but there always is going to be a one y-intercept. And if you recall, the way you find a y-intercept is you let x equal 0. We did this when we first started graphing lines. If we wanted to find a y-intercept, we took our equation and we let x equal to 0. Well, if I do that, I'm going to get 0 squared. I'm going to my original equation, plus 6 times 0, plus 5. And of course, this is 6 times 0. This is the x is 0. So this is 0, and this is 0. So what I'm left with is y equals 5. In other words, the y-intercept is the point 0, 5, right here. There's 0, 1, 2, 3, 4, 5. So that's one thing that we can find out, is not only can we find the vertex, we can also find where it's crossing the y-axis. What about if we want to find the x-intercept? So I'm going to have to, let me go over here. To find an x-intercept, we remember how to do that. In that case, we put the y equal to 0. We always do the opposite. When we want the y-intercept, we replace x with 0. When we want the x-intercept, we replace the y with 0. Now, if I go to my original equation, then that means I'm getting 0 equals x squared plus 6x plus 5. And it turns out that what I have here is a quadratic equation that has to be solved. In place of the y, we're putting 0, and we have to solve this quadratic equation. And this one we probably can solve by factoring. But remember, if we can factor, we can either use the quadratic formula, or sometimes we can even use the completing the square method. But this looks like it's factorable because remember, my AC is 5. It's positive, so we need two numbers that multiply to 5 and add to 6. So that would have to be 1 and 5. So this will become x squared plus 1x plus 5x plus 5. Splitting up the 6x into 1 and 5 and factoring, this gives me x times x plus 1 plus 5 times x plus 1, because my common factor here is 5. And now we have x plus 1 times x plus 5. Here's that equals 0. So when we get x plus 1 equal to 0, bringing the 1 to the other side, we get x equal to -1. And when I do x plus 5 equal to 0, I get x equal to -5. In other words, in this case, I got two x-intercepts. And look at it. Here's -1. And here's 1, 2, 3, 4, 5. Here's -5. So not only did I find my vertex, I found my x-intercepts and my y-intercept. And that's basically all they can ask you to do on a parabola. Most common question is to find the vertex. So I'm going to give you one to try and see if you can do this. Okay? And while you're doing this, I'm going to take attendance. Can I erase this? I know this got very messy. Can I erase this?
Don't erase the top because I'm still copying the top.
This part?
Yeah.
I can go from here?
Mm-hmm.
Okay, great. Okay. Here's what I want you to do. I want you to find the vertex, the x-intercepts, and the y-intercepts, and then sketch the graph. Okay, here's your equation. Y equals x squared plus 2x minus 3. Okay, so I want you to find its vertex, find its x-intercepts, find its y-intercepts, and then see if you could do a sketch of it. I'll give you about 5 minutes to try that. Okay, just listen for your name. Azia,
Yes,
good morning.
good morning.
Nashia Allen. Okay, I see Nashia is here. Annabelkis. Emma. Messiah,
I'm here.
good morning. Were you here on Friday?
I think I was, yeah.
Okay, you might have come on while I had before I took attendance or after I took attendance. Okay, change that.
Sorry, Professor, did you call Nashia?
Yes, I marked you here because I saw you.
Thank you, sorry.
That's okay. Corey,
Yeah.
good morning. How are you?
I'm fine. Thank you. How are you?
April,
Good morning.
good morning. Khadija. Khadija. Umar. Umar. Yakima.
Good morning, Professor.
Good morning. I had you absent on last week, Thursday and Friday. Is that correct?
That is correct.
Okay.
Uh.
Cheryl, I know you're here. Stacy, I know you're here. Denisha. Devana. Devana.
Morning, Professor. I'm here. How are you?
Yeah, good morning. I thought I could count on you to be here. Natalie. Natalie. Erica.
Good morning, Professor.
I see you. You didn't have any trouble with the quiz.
No, I was thinking too hard. I did good. Thank
I
you.
checked after you spoke to me, and I see I had automatically put it in for.
Oh, that's why. Yeah, I had a lot of time. Thank you.
Okay, good. Jonathan, I'm glad to see you back today.
Oh, thank you.
Luke.
Here.
Good morning, Luke.
Good morning.
Layla.
Yes, Professor.
Good morning. Ashley. Hi. Thanks for sending me a text. Kashira, I know you're here because we were talking. Jennifer, you were here. I know you're here. Rachel. Rachel here.
Yes, I'm here. Good morning.
Good morning. And Gloria. And good morning, Melissa. I see you're on. Okay. Okay, I'm gonna erase this top part so it shouldn't be in our way. And I'm just gonna move this up. Devon, I see you put it in what we call standard form. I'm not even gonna talk about that, but if you know how to do that, great.
Okay.
And it's actually a step above what we're doing. Okay, I think we could start working on it. At least let's get the vertex and the intercepts. Okay, remember, if we want to get the vertex, what's the formula? Anybody? How do we find the vertex? What did we say the vertex? What the equation for the vertex is? Right, great, Cheryl. X equals negative b over 2a. Now, for our particular example, the a, let's always write this down. The a, of course, is 1 because it starts out with just a plain x squared. The b is 2. And the c is negative 3. Now, if I want to do negative b over 2a, I'm going to have to do x equals negative 2, because my b is 2, over 2 times 1. So it turns out that I'm getting negative 2 over 2, which is negative 1. Again, that's just the x value of the vertex. To find the y value, we take this answer, negative 1, and put it into the equation. So we get negative 1 squared plus 2 times negative 1 minus 3, which gives us, well, negative 1 squared is positive 1. 2 times negative 1 is negative 2 minus 3. And when I combine all of them, 2 and negative 1 is negative 2. 1 and negative 2 is negative 1, and negative 1, negative 3 is negative 4. So my vertex comes out to be the point negative 1, comma, negative 4. Remember, when this only gives you the x value of the vertex. In order to find the y value, you have to stick it into the original equation. Okay. Now I'm going to give you time to see if you can find the x-intercepts. See if you can find the x-intercepts, where this is crossing the x-axis. All right, let's see if we can do that now. Remember, if we want to find the x-intercepts, we have to replace the y with 0. Make your y 0 so that you get 0 equals x squared plus 2x minus 3. And of course, in this case, your AC is -3, 1 times -3, which means you're looking for two numbers that multiply to 3, but when you subtract them, they're going to give you 2. Obviously, that's 3 and 1, and one's going to be positive and one's going to be negative. The larger number is going to be the positive. So we're going to break this x squared into positive 3x and minus 1x, because that'll give us two numbers that multiply to -3, but when we add them, will give us positive 2. And therefore, this becomes x times x plus 3. And here my common factor is -1, because there's a negative here. So this also becomes x plus 3. So I end up with x plus 3 and x minus 1. Those are equal to 0. So x plus 3 equals 0. Gives me x equals -3. And x minus 1 equals 0. And that gives me x equal to 1. In terms of the y-intercept, then we let the x equal to 0. So if I go to this original equation and replace the x with 0, I'm going to get y equals 0 squared plus 2 times 0 minus 3, which ends up equaling -3. If you notice, the c, -3, and the y-intercept are the same. And in all the cases in the parabola, that works out. If your c, whatever your c value is, that is your y-intercept. Okay, so now let's see if we can do a sketch. I'm going to do it right over here. Here's my x and y axis. The first thing I put on it is my vertex. The vertex is the point -1, -4. Whenever I'm going to check to see if I have the right sketch, it's always really the important point is going to be that vertex. Now remember, not only did we say the vertex, we also said it was opening up. But we can put in the other things that we know. We know that the x-intercepts are -3, so that's here, and +1, which is right here. And let me just, okay, so that's this and this. And the y-intercept we said was -3, which is right here. Those help us draw it, but they're not so important. But of course, now that we have it, here is what our parabola should look like. It opens up because the A is positive. The vertex is at -1, -4. And we have x-intercepts at 1 and -3. And a 1 y-intercept at -3. Any questions about this? Let's do one more.
Can you go for about the graph, Professor?
Yeah, what about I'm sorry.
Where the signs are, I don't understand where you put -1 and -4.
Here,
Yeah. Mhm,
here's my graph, right?
mhm.
-1, -4 means 1 to the
Oh,
left,
mhm.
4 down. 1, 2, 3, 4. So that's that point right here.
Okay.
Jennifer, yes, this is definitely going to be on the final.
My brain is about to blow up. I'm so
Okay,
this one, the rest of the other ones that you did, it was perfectly fine. But when we hit parabola, like I guess since it's so many steps, you have to find the vertex, the x and the y intercept is just oh my god.
so let me tell you, Jennifer, really what you're going to see on the final. The final, they're probably going to give you a parabola equation and say pick the right graph. They'll give you 4 graphs and they'll say which is a graph. They'll either do that. I'm going to check. Of course, I'm going to let you know further on. But what they're going to probably give you is just a case where you're going to have to decide whether that parabola opens up or down and where its vertex is. Because if you notice these extra things that took so much time, the x and the y intercepts, actually were not so super important for drawing the graph.
Okay, so we only have in test, we're gonna only have to find the vertex, and then the formula is what the one that you gave before, x equals
Negative b
A.
over 2, right.
And we'll figure it out and get the answer, and that's what we have to find on the graph.
Right. So let me give you one where that's all I want you to do. I'm going to give you a example. I'm going to ask you to find the vertex. I'm not going to ask you to find the intercepts, and I'm going to ask you to sketch it. Okay? Let's see if that comes out to be a little bit easier. I'm not saying you don't need to know how to find x-intercepts, but it's unlikely that it'll be asked on the final. Or if it would be asked, it would be the only question asked. It wouldn't be a question of you doing all of these things. So let's say it gave you this problem. I'm going to give you a tough one. Y equals -x squared minus 4x plus 5. And all I want you to do on this is to find the vertex and draw a sketch. Okay, so here's my equation. Y equals -x squared minus 4x plus 5. See if you can find that vertex and see if you can sketch it, the graph. Anybody want more time?
All right, Professor, can I explain something?
Yes, please do.
Okay, so I jot down the formula, right? And then I know that the A is gonna be 1, the B is gonna be -4,
Wait, what is the A gonna be?
1.
What is the A gonna be?
You see, this is why I told you. I put
Oh.
1.
What is the A going to be? What do you see in front of the X squared?
Oh, -1.
Right. Those negatives can kill you. You've got to be very careful and observant. What you did now was not a mathematical error. What you did now was an observational error. But those errors are the ones that can really give you trouble.
Yeah.
Wait, sorry. How is A -1?
Because it's negative
Look
squared.
at it. It's negative X squared.
But aren't those two different problems?
We're doing y equals negative X squared minus 4x plus 5.
I think you're talking about the first one, that one right there. The y equals X squared.
Oh, that one, I'm sorry, I should erase that.
Oh,
That was the one we did before.
okay.
Sorry, I forgot that it was still on the board.
Mm-hmm.
Okay, we're dealing, here, let me write it over here. We have y equals negative X squared minus 4x plus 5. And we want to find the vertex. So we know we have to do x equals negative b over 2a. But if I look at it, the a here has to be -1. Don't forget that when there's a negative in front of it, that's part of the coefficient. My a is -1 in this case. My b, what's my b in this case?
-4.
-4. And what's my C in this case?
5. And then
5.
after this, I'm lost.
I'm sorry, who said that?
Jennifer, after I know how to get all this, but then after
Okay, you're okay. By the way, this 5 over here is telling you what the y-intercept is. Remember, I said, not that you need to know it, but I know that the C is always going to give me the y-intercept. It's like y equals mx plus b. The thing that stands alone that doesn't have any x in it, that's always the y-intercept. Okay, now we have these 3 numbers. We know we want to find the vertex. By the way, before I even go to find the vertex, is this parabola going to be one that opens up and looks like a smile? Or is it going to be one that opens down and looks like a frown?
Opens down?
Down.
Yes. How do you know it's going to open down?
Is a negative.
A is negative.
Because the A is negative. Don't say it's negative, say the A is negative, because there are a lot of it's over here. But yes, this is going to be a opening down parabola. Now let's find the vertex. Here's my formula. It's negative b, so it's -4 over 2a, so it's 2 times -1. All I'm doing is I'm putting a parentheses and substituting those numbers. Well, let's see what this works out to be. -4 is +4. And 2 times -1 is -2. And 4 divided by -2 gives me -2. I see, Azio, you got the whole thing, and yes, the x part is -2. But again, remember, this is a point. A vertex is a point, so we need that y value as well. So how do we find the y value? We go back to the original equation, and wherever I have an x, I'm going to put -2. So this is going to be negative. Here's my x, it's -2. I always put a parentheses in place of the letter. Squared. -4, here's my next parentheses for x. Again, I put that -2. and then plus 5. Okay, now I just have to be careful. This is not hard. This is a matter of being careful. Remember, -2 times -2 is +4. So -2 squared is 4. So this becomes a -4 because there was a negative in front of that parenthesis. This is -4 times a -2, which is +8 because a negative times a negative is positive. And this is +5. So -4 plus 8 is 4. 4 plus 5 gives me 9. In other words, my vertex, here's my vertex, is the point -2, 9. Azia, yeah, that's exactly what you gave me. Yes, perfect. And now I can really do a sketch because all I need is the vertex and the direction. Here we are. Here's my graph. Here's what I look for. I go to the point -2, 9. So here's -2 is to the left, 9 is up. 1, 2, 3, 4, 5, 6. I'll go further. 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Here's 9. So here we are. This is where that vertex is. And I know it opens down. I probably didn't hit this at the right spot. It might have been here. But all I really, for a sketch, is need this and the direction. And I've got a good sketch of what's going on. And if I had to pick out the right answer, I would be able to pick out the right answer. Jennifer, does that make it easier for you?
Yes, it did.
Okay, so really, essentially, this is what you have to know. Okay, so we really have now finished this chapter that's called conic sections. Remember, we did 4 types of shapes: a circle, an ellipse, a hyperbola, and a parabola. You really, at this point, should be able to look at an equation and without doing any work, decide whether you have which of the shapes you have by just looking at the equation. Remember, what characterizes a parabola is the fact that only one of the variables has an exponent of 2. In the other 3, both the x and the y had exponents of 2. But in this one, only one has the exponent of 2. And it's always a U-shaped. Again, the hyperbola was also U-shaped, but it was 2 U's back to back. This is a single U, and sometimes it opens up, and sometimes it opens down. And you could just look at the number in front of the x squared. If it's positive, it's smiling, it's opening up. If it's negative, it's in a bad mood. Somebody who's negative is in a bad mood and frowning. Okay, so now I want to go on to, we have basically 2 chapters left to do. One is a chapter that's not even in our textbook. You won't find this. It's what we call an introduction to trigonometry. And actually that's what I'm going to do now. It'll probably take us into Friday. We'll start today. It'll take most of Thursday. We should be finished by Friday. And the next chapter is the last chapter that we do, which is the last chapter in the book that we haven't covered, which is chapter 8. That's the last topic we're going to be doing. As I said, starting Thursday, we're going to be starting to do, part of the day is going to be left to review. Now, what I'm asking you to do is, if you have a specific topic that you really feel you want to review first, please send me an email. If not, I'll just do the review basically in the order that we covered the chapter. In other words, we'll first go over regular equations, and we'll go over inequalities, and we'll go over absolute values. We'll do it basically in the order that we covered all the topics in the course. And again, be on the lookout for this review sheet that I'm going to be sending you, the study guide that I think can be help, because you won't have to go through all your notes, but it will have all the topics very succinctly put together. So you'll remember, if you don't remember how to do let's say you don't remember the equation, the formula for a vertex. You can go to that sheet and you're going to go to parabolas, and you'll see the formula for the vertex. In other words, all the formulas, all the types of things that we learned that you have to know how to do, that's going to be on that sheet. Okay, so we're going to start this new topic of trigonometry. Those of you that are going on to Math 151, pre-calculus, a very major part of that course, I'd say almost half the course, is about this topic of trigonometry. And of course, we're just doing an introduction. What are we going to introduce here? We're going to introduce the basic words and interpretations of these for this topic. In other words, if I'm going to say find the cosine of an angle, you're going to have to understand, what does that word mean? So I'm going to be doing that, and how to take the words and actually translate them into the numbers that are called for. And that is going to be the main part of what we're going to do. In other words, there are many things that you can do with these things that are called sines and cosines and tangents and whatever. We're just going to stick with the basics. What do they mean? How do we find them? Now, before we even go on to, now that I'm talking about things that you might sound like it's Greek, and it's a good reason it might sound like it's Greek, because probably these things were first used by the Greeks when they were doing their mathematics. So you're going to see, we may even be using Greek letters, because this is really a very, very, very old topic that has pertinence even to today. The word trigonometry sort of tells us what we're going to be studying. The prefix is tri. Tri means something. It has three things. Metry comes from the word meter or measurement. So we're measuring something that has three things. And actually, trigonometry is really an offshoot of geometry, of the study of shapes. And the particular shapes that we're going to be talking about are those shapes that have three sides. Now, you know, those are called triangles. And we're going to be doing something called right triangle trigonometry. So before we even approach what that is, we better talk about what makes something a right triangle. And we know that if we have a triangle, it's a three-sided figure. It's the simplest figure we could draw with straight sides, because if you don't have at least three sides, you're not going to be able to close it up. If you have just two sides, how are you going to close it? So you need at least three sides for a straight-sided closed figure. Not only do you have three sides, but of course you're going to have three angles. That's where the word triangle comes from, three angles. Usually, when we're talking about triangles, we use capital letters for what we call the vertices, or the angles of the triangle. This is angle A, this is angle B, this is angle C. We put capital letters for the angles. Right. Absolutely, Corey. And the sides can be labeled in two ways. One way is if I want to talk about this side, I could say find side AB. If I put AB with a little line on top of it, it means I'm talking about the side of the triangle that goes from A to B. Obviously, that's pretty descriptive, but it's when I want to use it, it's not so simple, because I have to locate the A and I have to locate the B. There are two things that I have to locate. If I say find angle C, there's only one place to look for it. I don't have to find two things and then connect them. So in order to make it a little bit easier for the sides, not to have to use two letters, we sometimes do another way, we have another way of labeling the sides. Since we use capital letters for the angles, what we do is we use lowercase letters for the sides, and in a very particular way. If you look at this side over here, it's right across from angle C. It's directly across. It's not attached to angle C, it's across. It's directly across. We're going to call that side small c. Then this side over here, which is directly across from the angle A, is going to be called A, small a. And obviously this one is going to be called small b. So, and that's the way we're generally going to approach labeling triangles. Capital letters for the angles, for the vertices, that's what they're called. A is a vertex, B is a vertex, C is a vertex, it's a corner. And lowercase letters for the sides, particularly, and you can't just put those letters indiscriminately. They go in a very specific way that the capital and the lowercase are always across from each other. The A and the A, the B and the B, the C and the C. That's for any triangle. What makes something a right triangle? Corey was absolutely right. It has something called a right angle, which means the angle has 90 degrees. Now, when we talk about a circle goes around in a whole circle, it goes 360 degrees. You know where that 360 number came from? Just strange number. It actually is not a mathematical number. The 360 comes from the fact that it takes a whole year for the Earth to go around the sun. Now, it takes 365 days, we know that. But rounding it off to a simpler number, we rounded off to 360. So the whole circle is given 360 degrees for each day, how long it takes the Earth to move each day. 90 degrees is how much it moves in one season, because it's a quarter of the circle. And when we talk about it, of course, has nothing to do with mathematics, and you don't have to remember anything that I just said. But what 90, this you do have to know. You have to know what a 90-degree angle looks like, and it looks like a square corner. And if you think about it, it's probably the most common shape you're going to see when you look at real life. Remember, shapes are part of real life. Most shapes, whether your windows or the corners of your room or the desk or my blackboard, which you might not be able to see the corners of, are 90-degree angles. So this 90-degree angles, which is something called a right angle, is the type of angle that we're going to be looking for in our right triangles. We're going to be looking for triangles. This was not necessarily a right triangle. Here is an example of a right triangle. This has a 90-degree angle. And very often, to indicate that this angle is a right angle, we put a little box in it. So you see that it looks like a little square box, because that's the type of angles that you're going to see in rectangles and in squares. Now, when we label our right triangle with the letters A, B, and C, we usually put the A and the B at what we call the acute angles. An acute angle is an angle that's less than 90 degrees. And the C is at the right angle. That's usually the way it's done. It doesn't have to be done that way, but usually we mark the C, the capital C as a right angle. The A and the B are what we call the acute angles. Now, acute angles are angles that are less than 90. How do I know that the A and the B have to be less than 90? Because in any triangle, not just right triangles, but in any triangle, the sum of the angle A plus the angle B, this is just a symbol. This is actually a symbol for angle. So the sum of angle A plus angle B plus angle C in any triangle always adds up to 180 degrees. So one of the angles we know is 90. So the other two together add up to 90 because all three of them are going to be 180. And if that's the case, obviously neither A nor B can be bigger than 90 because together they're adding up to 90. So the biggest A could be is, like, say 89 degrees. It can't be bigger than that, or 89 and some, but it can never be up to 90. Again, this rule about the three angles adding up to 180 degrees is for any triangle. In a right triangle, since one angle is 90, the other two angles also add up to 90, so that the whole sum comes out to be 180. Now, let's go and label our sides. This is going to be side C because it's opposite the capital C. The side that's opposite the right angle is called the hypotenuse of the right triangle. I don't know where that word came from, but it's a word that we have to know. If I use the word hypotenuse, it means the side that is across from the right angle. This side is going to be small a, and this side is going to be small b. A and B are what are called the legs of the right triangle. So there are two legs to the right triangle and one hypotenuse. And one of the most important formulas that have to do with right triangles is something called the Pythagorean Theorem. And what that tells us is that a squared plus b squared equals c squared. This only works in a right triangle. In a right triangle, the two legs squared, when you add them, equal the hypotenuse squared. A squared plus b squared equals c squared. Now, where does this word Pythagorean come from? It's named for a Greek mathematician called Pythagoras. And it's such an important theorem that we should all know that they gave, it was such an important thing that he discovered that his name was given. But again, see, this goes back to Greek times. This goes back more than 2,000 years to when the Greeks were in their glory in Athens, and their mathematicians were very highly skilled for those days, and they came up with this formula. Now, what I'd like to do is just do one or two problems using the Pythagorean theorem so that we can start from here when we start talking about it. Let's say I have okay, let's say I gave you this. So this is from one of the exams, the final exam. So here I have a right triangle, and I'm told that this side is 9, and this side is 5 radical 3, and we're asked to find the third side of this right triangle. And we're going to try and do it both in radical form, if it comes out to be in radical form, and also as a decimal. So let's label this side. This is small c because it's opposite from the capital C. This is small a because it's opposite the capital A. And this is small b because it's opposite capital B. And since I see this little square corner, and they actually probably told me it's a right angle, I know that the Pythagorean theorem that the a squared plus the b squared has to equal the c squared. Now you're going to see why it's important for us to have done a lot of the previous work that we've done. Let's put in these numbers. Well, the a I don't know, so I'm going to leave that a squared. The b I know is 5 radical 3 squared, and the c is 9 squared. So we have to simplify this. This stays a squared. Okay, so the next thing is to do the 5 radical 3 squared, which means I'm doing 5 radical 3 times 5 radical 3. Now you could, if you want, put it into your calculator with parentheses, exactly the way this looks. Parentheses, 5, press your square root button, put in your 3, close your parentheses and press your square button. Otherwise, I'm going to do it without the calculator. Well, I know when I'm multiplying two things with radicals, I multiply the numbers outside together. So the 5 times the 5 is 25. And I multiply the radicals together, and radical 3 times radical 3. Remember, when you multiply a radical by itself, it just gives you the number. So this becomes 25 times 3, or 75. So therefore, this becomes a squared plus 75 equals 9 squared, which is 81. And now to find out what a squared is, I'm going to subtract 75 from both sides. Okay, I'm going to go over here. That'll give me a squared equals, well, 81 minus 75 is 6, which means that the a, remember we know that square root property, a is going to be the square root of 6. And I don't do plus or minus. I can't have a negative answer because these are sides of a triangle. The sides of the triangle can only be positive. So in radical form, my answer is radical 6. Now, sometimes we want our answer as a decimal. If somebody was building a house, they don't want to have the side of a triangle being radical 6. They want to know it in inches. So let's say they asked us to find the answer to 3 decimal places. How do we go about it? Well, that's not hard. I take out my calculator. I hope everybody knows where their square root button is. I press my square root button. I put in 6 and I press enter. And what I get is 2.4494897, etc., etc. They wanted me to go to 3 decimal places, so they want me to stop right over here. Remember, I always look at the next place. If it's 5 or more, I have to round up, but this is less than 5, so my answer becomes 2.449. So if they ask for an exact answer, that means an answer in radical form, this is the answer. If they ask for a decimal answer, that's the answer in decimal form. Okay, so this is where we're going to leave it for now. Don't forget, there is a quiz on Delta Math that you are responsible for. It has to be finished by Friday for full credit. Otherwise, you only get 90% of the credit. If you're missing any other tests, you better be doing them now because you are, yeah, Jennifer.
How did you get the decimal? You put the radical 6?
Yes. What about, I'm sorry.
How did you get the decimal in the calculator? That's what I'm trying to figure out.
Okay. Which calculator do you have?
The Texas Math instrument.
Look down the first column. Do you see x squared?
Mm-hmm.
What do you see above the x squared?
Hold on.
Not on the button. Right above the button. Here, you have it looks like this, the x squared, right? And then you have something like that. Is that what it looks like?
Yeah.
Okay. Anything that's written above it means that you first have to press what's called the second button. There's that second button all the way in the top.
So put in that.
Press that button and then that button.
Okay.
And you should get and you get that?
Yeah.
Then type in 6
Okay.
and then press equal.
Okay.
And did you get that? Okay, so now we talked about, I forgot what I was talking about. Okay, so we've started this topic of trigonometry. We talk about the Pythagorean theorem. What the Pythagorean theorem allows us to do is that anytime we have a right triangle, it only works in a right triangle. If you know two sides of the right triangle, you can always figure out the third side. Always put it into the formula. Notice you don't just do this squared plus this squared. You do a squared plus b squared equals c squared. You stick it into the formula and you work it out. And it's not a hard formula to use, and it allows you to find the third side of that triangle. Okay, so we're going to continue from here next time. All right. Again, if you're missing any tests or anything of that nature, and you need them opened up, or you took a test and you didn't like the mark and you want to redo it, I can reset it for you. Just let me know. Okay?
I want to take it again because I got a 90 and it pissed me off at the end. I forgot to put the radical, so I want to get 100. So I want to do it again.
Okay, so you know what, Jennifer? I won't make you take the whole test again.
It was the end. It was just I just missed to put the little radical sign, and it was the right solution. And I was doing it fast, and I didn't put the radical sign, and it marked it wrong.
So here's what I'm going to do for you. And I'll do this for anybody. If you want a better mark on a test and you got 2 wrong or 3 wrong, I won't make you do the whole test again. I'll just reset the ones that you got wrong.
Yeah, I'll just need that one last one is the last question.
And I'll give you extended time so that you'll have time to do it.
All right, thank you.
Okay.
Oh, wow, Professor, that's awesome. Thank you. Thank everybody. Thanks.
But you have to let me know you want me to do this, otherwise. Okay, so just email me because I'm not going to remember unless I see it on black and white. I can't remember who said what to me. I'm getting to that age where I don't remember things as well as I used. But I guess I have a lot to say thank you for. So if my memory is not as great as it used to be, at least I remember my Pythagorean theorem. Again, and I will be sending you out that study guide. I think you should print it out. I think probably if you print it out, it'll be more helpful. I don't mind if you use it during tests or whatever. Obviously, you can't use it during your final, but if you use it during the test, I don't mind. Okay?
Okay.
So we'll see you on Thursday, everybody.
Okay, bye-bye.
Remember to send me 2, please.
Thank you.
Should I'm going to make you the host, Melissa?
Yeah, but also send me the cheat sheet. Not cheat sheet.
Yeah, I will.
All right.
I will. I'll send it through through Blackboard, so then you should get it. Okay.
Okay.
Okay, Melissa, I'm going to make you host now and let you take over for me. Thank you. Have a great day.
Hey, what's up?
Okay.
Hey, girl.
Eh,
Well, my eyes are really
All right, but
like burning right now, so I'm gonna see if I can like look at the screen. If not,
Mm,
I'm gonna call it
the allergies
on one eye.
mine as well.
Hmm?
Mine as well, like gravel, but I know it's the allergy, the pollen.
Yeah, I think I don't even know because I don't really have allergens like that. Maybe it's because I keep staring at the computer. I'm not sure.
Could be too.
I know that you guys are confused with the ellipse and
Yes. The parabola.
yeah, the parabola. Well,
Mhm.
the thing that I realize about it is like the circle and the parabola is somewhat the same. They just have different sides.
Mhm.
That's all I think. And how to work it out. I
Mhm.
think it's pretty simple.
Okay.